This is Matthew Erb's video project, and I had the 2023 question 5 BC exam. And for this question, it gives you a graph of the function f of x and the bottom function g of x. And it says the graph of the functions f and g are shown in the figure for 0 and 3. It is known that g of x equals 12 over 3 plus x for x greater than 0. The twice differentiable function f, which is not explicitly given, satisfies f of 3 equals 2. And the integral from 0 to 3 of f of x dx equals 10. Question A is asking if to find the area of the shaded region enclosed by the graph of f and g. Question B is asking to evaluate the improper integral from 0 to infinity of g of x squared dx, or to show that it diverges. And then question C, it says let h be the function defined by h of x equals x times f prime of x, and it asks us to find the integral from 0 to 3 of h of x. To find the area enclosed by the two functions, we have to find the area of the function. And to find the area of the function, it's integral from the start to the stop, and then it's this area below it. Therefore, as shown on the screen, the function f of x, that's the area below it, and this is the area below g of x. So now looking at the integral, it's from 0 to 3, f of x minus g of x dx, which then we can separate it to be integral from 0 to 3 of f of x minus the integral from 0 to 3 g of x. We see that in the problem, it states that the integral from 0 to 3 of f of x dx equals 10, and that g of x equals 12 over 3 plus x, which now knowing that, we would replace it into our equation. Now moving over, we can do a simple u sub. I made u equal 3 plus x, which then we can find the derivative of both sides, so du equals dx. So then we can replace 3 plus x with u, and dx with du. Now I took the 12 out, and then I replaced 3 plus x with u, and then doing integration, the 1 over u will become ln, so it's 12 times ln 3 plus x from 3 to 0. Now after plugging in 3 and 0, we get 12 times ln of 6 minus ln of 3, and because of its ln, two ln's subtracting each other, it will be ln 6 over 3, which is ln of 2. So now it's 12 ln 2, which we can put it back into the original thing. So 10 minus 12 ln 2 is our final answer. Now talk about the scoring for question 5, part A. The first point goes to the integrand, which that's what we did at the very beginning. The second one is the antiderivative, which that's after we made the derivative from 0 to 3 of f of x, which will equal 10, which that already is anti-derived for us by the equation, and then replacing g of x with 12 over 3 plus x. And then now for the third and final point, after plugging in 3 and 0 to the ln and simplifying everything, we get 10 minus 12 ln 2, which was what I showed previously. This problem is really simple if you know how to integrate, and it's not really trying to trick you. So if you understand how to find the area under a curve and how to do simple u sub, you shouldn't be tricked by this problem, and it's pretty easy. Now for question B, it is asking to evaluate the integral of 0 to infinity of g of x squared dx. For these next couple of steps, I replaced g of x, which equals 12 over 3 plus x, and then I squared the top and the bottom, which 12 squared is 144, and then I left 3 plus x squared. And then for this part, it's another u sub, u equals 3 plus x, and derivative of both sides is just du equals dx, which then I replaced 3 plus x with u, and I replaced dx with du. And then I took the 144 out, and then I put u squared at the top, so it's a little easier to read. Which then I use power rule to find that u to the negative 2 is just negative 1 over u. And then also when you integrate and having an infinity in one of your endpoints, once you're done integrating, you have to do limit as any number. I just chose b is approaching infinity, and then you have to put that in on your end line. I then simplified a little bit to limit as b approaching infinity of negative 144 over 3 plus x being 0. I then plugged in b and 0 to give me limit as b approaches infinity of negative 144 over 3 plus b plus 144 over 3. And because b is going to infinity, the whole negative 144 over 3 plus b is just going to become 0. So then the final answer will be 144 over 3, which equals 48. Now for the scoring, the first point goes to limit notation. Because in the integral it's to infinity. You can add limit of b approaches infinity, but I'm pretty sure for the integral it's fine, but for after you integrate, it's not allowed. You need to have limit of b approaches infinity, and then having the b at the end after you integrate it. The next point is pretty simple. It's the antiderivative, which is where I did u sub, and it's I took the 144 out, which is u to the -2, which is just a simple power rule. And then finally for the answer, you have to recognize that limit of b approaches infinity of -144 over 3 plus b will become 0, because when the bottom of a fraction goes to infinity, that means it's being divided by an infinitely greater number, which will make it equal 0. So then basically 0 plus 48 will get you just 48. This one, again, just like all the parts of question 5, are pretty simple and aren't trying to trick you. The only thing that could be a little annoying is to forget the limit of b approaches infinity, but other than that, it's an easy problem. For part C, it tells us that h of x equals x times f prime of x, and it wants us to evaluate the integral from 0 to 3 of h of x dx. While doing this problem, it should be pretty clear that we need to use parts, which then u equals x, and then just integrating that du will just equal 1, which is just 1 dx. And then dv will be f prime of x dx, which integrating that will just give us f of x. Our next step is to remember the formula of parts, which is just u times v minus the integral of v du. And so just plugging that in, our u is x again, so it's just x times f of x from 3 and 0, minus the integral from 0 to 3 of f of x dx. And at the top, it tells us already that 0 to 3, the integral from 0 to 3 of f of x is 10. And then we have to find the left side, which x equals 3, so it's just 3 times f of 3. And at the top, it also tells us f of 3 does equal 2, so it's just f times 2. And then the rest also is 0, so it's 6 minus 0, which is just 6. And then finally, 6 minus the 10 would equal -4. Now for the scoring guide, the first point went out to knowing it was parts and choosing u and dv correctly, which is pretty simple because you can see using the pattern of parts that f prime of x needed to be integrated. And then after doing the parts, you can integrate it, and we'll see that the next point, you're just integrating by parts. And for the last point is just wrapping it all together, finishing the integration, plugging in your 3 and 0, and also the integral from 0 to 3 of f of x equals 10, and then the 6 minus 10, which does equal -4. And again, just like every other part in this problem, nothing's really trying to trick you. There's nothing hard that will mess you up. Overall, for question 5 on this AP exam, it shouldn't be hard at all. It just requires basic integration of u sub parts, or for question A, it just gives you the answer for the first integration. So just look out for what's in the question, and also just know simple is easier. Thank you for listening.